Hi there and welcome to my tutorial on making a 2D platformer. We're just going to get started straight away. We're going to start creating the character that we're going to use. We're going to use some very simple geometry just to do this. All I've done is I've created an empty game object right in the middle that I'm going to call player, and I've reset the position so it's absolutely in the center. This will be handy when we turn it into a prefab. And then we're going to add the character controller onto this. Just like in my 3D tutorial, we're going to add in the geometry as a child of the main object, because that way we can easily swap it out when we have an artist that's finished our model, or if we want to find a model from somewhere else. So for now we're just going to use a really simple capsule, and we're going to also put something, a cube, a box on there, just so we can see which direction it's facing. So if you just create yourself a cube as well, I'm just going to scale that down and position it up so it's sort of close to his eyes, so that it looks like a pair of shades or something like that. I'm just moving this into place now. Once this is you've got it where you approximately like it, so you can see it sticking out. I think I might put some materials in there as well, so just to keep organised, make a folder for any of the things, just to keep my project organised so it doesn't get too messy. So I've created a materials folder, and I'm just going to make some materials in there just to give the look of this a little bit, make it look a little bit nicer. So start with a red material, and I think I make the body of the character red, and maybe once we've done that we'll add in another one. We'll do maybe make the eyes a black colour. So just add those materials in and just drag and drop them straight onto your object. Right, so we've managed to get that. So what we need now is our platform. So just a little test platform right now. So I've created an empty cube object, call it platform, and just bump the scale up a little bit so we can slide along it when we start writing our code. We can test it. Okay, go with 10, and maybe also change the colour of that so it doesn't look so bad. So I've made it I made it 0.5 height as well, so it looks a little bit skinnier. And I'm also going to make a green material and put that green material onto the platform so the thing looks a bit nicer. And you'll notice when we play, absolutely nothing happens because we've not done anything with the code. So the next step is to get ourselves some code. So we're going to put this code straight on the top level player. So remember, that's important. The character controller is actually on the top level player. So making a scripts folder to keep myself organised, and inside that scripts folder make a C# script. I'm going to call this player movement. And then we're going to open up this script, and we're going to create the player movement. And just as this loads up, it's going to be nice and simple to begin with. We're just going to access the character controller component and make it move right and left, just so we can see that we can do that. So Visual Studio is fired up right now. At the top of our code over here, we're just going to get a reference to the character controller component. So this is quite common if you've done any coding before. So a character controller type, and call it CC, and then inside the start function we're going to call CC equals, and then we're going to say get component character controller, and then the parentheses at the end with a semicolon, and then we can take some input. So we'll just create a temporary float variable. We'll call this x input, and then we'll get the x input from the input manager. So input dot get axis brackets inverted commas and then horizontal, and this is a built-in access to Unity. So once that's in, we should get a value between -1 and 1 based on the right and left keys that you press, or the A and the D keys. So we're going to try and act upon that right now by accessing the CC that we've got. So the character controller component, we're going to use the dot move. This takes a new vector 3, so if you type in new vector 3 and then a brackets, and then we'll pass in some values that we want. So we'll just pass in the x, the x, and then a 0 and a 0, oh, sorry, x input, and then a 0 and a 0. So this will take the -1 and 1 and translate it into that x movement. So just quickly test this just to make sure it's working. So if you press play, oh sorry, I forgot to add the script on. If you press play with that script on, you should see that the character moves right and left. And the next part we're going to add is a little bit of some movement based on time. So if you just want to multiply that x input by time dot delta time, then it will be frame independent, so it won't move a ridiculous speed. Also, we're going to make a public variable up the top, a public floating point variable that will be the movement speed for this particular player. So maybe make this just 5. And then you can multiply the x input by the movement speed and by time dot delta time to give you a reasonably consistent movement as you move the character around. So final test, if we wait for this to kind of compile and then just run this, you should see that the right and left makes the character move right and left quite nicely. And the next one, we're going to add in a little bit of gravity next. Right, so we're back into our code now, and what we're going to do is we're going to create gravity that we need. So let's just very quickly start by creating a couple of public variables, or a couple of variables up the top that we're going to need. So first of all, I'm going to make a floating point variable. I'm going to call this gravity. I'm going to make it equal to -15. What we're also going to store is the y velocity. So I'm going to call this y velocity so that we can track how fast we are moving down. So if I save this and head down into the main part of the update, so we can pretty much ignore this x input part. We're happy with that. The x velocity calculation is okay as well, so I might just put those two together, and then we want to do the next part, which is calculating the y velocity based on whether it's on the ground or not. So I'm just going to do an if statement and then double tap tab to give me my code blocks, and then I'm going to say if cc.isGrounded. Now this is really handy. This is something that isn't done in the 2D thing, in the 2D sprites, so you have to do all this raycasting yourself, but this cc.isGrounded is awesome. So this basically says if the thing is on the ground, what we're going to do is we're going to say are we jumping? So we're going to do another if. We're going to say if input dot get button down, and we're going to this time use the jump button, and that by default is set up as the spacebar inside of Unity. So if the button is down, we're going to make the y velocity equal, I don't know, let's make it equal 10. We can make that a little bit better later on by putting that as a public variable. So otherwise we want the y velocity to be equal to 0, so we don't want it to be moving when it's on the ground. We don't want it to increase its velocity downwards when it's on the ground. The last little thing that we need to do is apply the gravity. So I'm just going to say apply gravity. That'll comment in there. It's always good to do them. So I'm going to apply the gravity, and what I'm going to do is I'm going to say the y velocity minus equals gravity times time dot delta time. That will multiply gravity times time. Now the next thing that I should probably do is I'm going to need to pass this y velocity into this slot in here inside the movement, And it seems really weird that we're doing this, but we're going to multiply it by time dot delta time again. The reason for that is gravity is an acceleration, so it's like velocity squared. So even though I'm multiplying by gravity by time here, I'm also multiplying it again here for its gravity squared. So if I test this, it's a fairly simple method. If we test this right now, we should see once it's compiled that when we play, we're able to drop to the ground. Oops, and show up in the sky. The reason for that is I made gravity negative and then I subtracted it again. So let's just say add gravity, which means downwards because we've got gravity set at 0. So hit the play button again once this compiles, and we'll go the right direction this time. So we drop to the ground. We can still move right and left, and when we hit the space bar, we'll see we jump and we come down nicely with gravity. So more or less we have just about a character controller ready to go. What we're going to do now is probably just make it turn around as it's going in different directions. And the last thing we're going to do is just make it turn around. So this is fairly simple. If we jump back to our code, we can do this in a complicated way or a really simple way. The simplest way is if we just do a couple of if statements. So if the x input, so the button that you're pressing, is greater than 0.1, that means we're pushing to the right. What we're going to do is we're just going to set the transform dot rotation to equal, kind of does seem a bit complicated when you get it, quaternion dot Euler. What that means is, so this rotation is the rotation of this object. We're going to set it to either 0 or 180 on the y, but because we want x, y and z, we need to turn the rotation, which is a quaternion, into a Euler, which is an x, y and a z. It's something that a human can actually picture. So we use quaternion dot Euler. So we're going to type in the values that we want. So we want it to be 0, 0, 0, which it should be at right now by default. And if the x input is less than minus 0.1, we want to do the same as we did before. Transform dot rotation equals quaternion dot Euler, and this time we want it to be 0 and then 180 and then 0, and we'll just put that as it is. Now if I just test that this works, this should be no problem at all. Just move out the way we go. So it's compiled. If we hit run, we should be able to move right and left, and it will immediately snap to the right and the left. And if we're going with a really simple concept, we could just go with this. If you want to stop the video there, you can we can go on to the next part of the video, which is the start of the rest of the gameplay. But if you want to stick with it, we can make this a little bit nicer. What I'm going to do is I'm just going to add in a value for the rotation, because I'm going to smoothly interpolate between one and the other. So I'm going to say y rotation, and I'm going to make that equal to 0 at the start. And then what we'll do is we will set this, rather than directly set it inside of these, what we're going to do is we're going to set the y rotation to be equal to the value that we want. Oops. And the y rotation should here be equal to 180. And then down the bottom here, what we're going to do is we're going to get the current rotation. So we want it as 3 values, as a vector 3. So we're going to say vector 3 rot equals, and we're going to get that from the transform. So we're going to get the transform dot rotation, and we're going to get that as Euler angles. There we go. So that will get an x, y and a z value that we can work with. So then we're going to say that the y component of this, the y angle, is equal to, and we're going to use the lerp, so mathf.lerp, which means to interpolate. So we're going to rotation.y, so we're going to lerp the current one to the desired one, the Y rotation, and we're going to do this over the time that we're going to do. So I'm just going to randomly make up a value that we could maybe put as a public layer. So this is the speed that it's going to turn around, so I'm going to say 5 times time dot delta time. So there we go. That will move at a reasonable speed to point in the direction that it wants rather than immediately snapping to it. Now that we've recalculated that, we're just going to say that the transform dot rotation equals that. So we can't just put it in as a vector 3, so we're going to say quaternion dot Euler, and we're going to pass in rot to that. So complicated way to do it, but it should be a fairly nice result. If we just compile this now and run it, what we should see, I don't know which way it's going to turn actually. Oh yeah, that's going to turn the right way. So what we see now is if we move right and left, it slowly turns. Now 5 might be a bit too slow, so I might want to snap it a bit faster. It kind of feels like it's drifting, so maybe double that and see what it looks like, and then we'll move on to the rest of the gameplay inside of the 2D game. Oh yeah, it's a bit better. And we can still jump and turn. Alright, I hope you've enjoyed this, and join me for the next part of the videos.